Hello everyone, today I will be explaining 5 technical questions from the CCNA exam. Let's start with the first question. The first question asks us to consider how we can make absolutely certain that a specific switch is always without exception the root bridge in VLAN 750, which is a critical role in spanning tree protocol because the root bridge determines the optimal path for network traffic within that VLAN. So how do we make sure it is always the root bridge? We do this by setting its priority because the lower the priority, the more likely it is to be selected, right? We set its priority to 0. So the correct answer to this question is, without a doubt, B. Choose B. All right, let's look at the second question. The second question asks us to look at this diagram. These two switches, well, these two hosts, their ping test failed. That is, when host A tries to ping host B, the ping fails. Now, based on the output results shown below on the switch, let's correct the error. In other words, let's find out where the mistake is. Where exactly is the problem? The diagram might not be very clear, like this. Where is the error? Let's take a closer look at the output here for a moment. Their VLANs, both of them, as you can see, are 99, right? Then on switch 1, this interface and also this interface, both are in VLAN 1. So there's one thing that's actually different. Its native VLAN, the original VLAN, is VLAN 1, which by default is the default configuration setting for most switches, unless it has been changed. On the left, this SW1 uses the default VLAN 1. But on SW2, it has been changed and set to 99. So at this point, if these two, the native VLANs at these two places, are different, then data won't be able to get through. First, when the data comes in here, and I want to send it out from the middle here, this place is, this is the trunk link. Once you send it out from here over the trunk link, it needs to be tagged with 99. So after tagging it with 99, it is compared with the original VLAN. The original VLAN is 1, and here it's 99. When we compare 99 with 1, if these two values don't match, then we look at which VLANs are allowed, right? If VLAN 99 is allowed through, then it will carry this tag as it passes through the network and is sent over here. So this tag right here is 99, correct, right? Then when it's compared with my VLAN 99, if they are the same, the tag will be stripped off. After the tag is removed, it becomes an untagged frame and is sent over here. But if it's 99 and doesn't match, it can't be sent through and the connection is interrupted. So this is the issue of the original frame not matching. Let's look at the original question. For this question, choose D. Its original frame does not match. The original tag doesn't match. Okay, let's look at question 3. The third question asks, which specific type of access mode, more precisely, referring to the operational mode that is configured on the access point device, would actually result in a situation where a connection failure occurs between the Cisco wireless controller and the access point itself. In this scenario, even though the controller and the access point are unable to establish a successful connection, users who are connected to the network can still be provided with normal wireless service and are able to access the internet without any noticeable disruption or interruption. This situation only occurs with flexible deployment, right? Only with flexible deployment does the authentication happen on the AP itself, correct? No matter what kind of switch I connect above, and even if there's a controller on this side, if the Cloud WAN tunnel between them goes down, users can still access the internet. It doesn't affect the users at all. So this proves that the authentication point is on the AP, which means we should only choose C. Choose C. All right, let's look at the fourth question. For question 4, let's look at this diagram. Based on this diagram, it asks which command can produce this output. So, which command did we enter to get this kind of result? First of all, option A says it's the routing table, meaning it's used to view the routing table. But there are no characteristics of a routing table here, right? There are neither source nor destination addresses. So, option A is incorrect. This is not a routing table. Next, the second one is about CDP neighbors. My device is directly connected to this device, and then they send CDP packets to each other. In this way, I can easily detect who my neighbors are, what specific functions they have, and which interfaces, specifically, which of my neighbors' interfaces are actually connected to mine, right? This is the local interface, and this is the neighbor's interface, and then the neighbor's name, right? So, with this information, I can clearly and accurately identify the relationship between my device and its neighboring devices, as well as understand the precise connections involved. So the correct answer is B, CDP neighbor. B, right? And then show IP interface is definitely incorrect. And this one is even more wrong. Show interface just checks the physical interface, while this one checks the configuration on the logical interface. So for this question, the correct answer is B. All right, now question 5. For question 5, they ask, which specific mode must we use? Meaning, which particular mode is absolutely required in this scenario? And then when configuring the switch, specifically the switch's Ether channel, which is also referred to as a port aggregation interface. If we configure it in a certain mode, it doesn't require any negotiation and can be established automatically without any additional steps or manual intervention required, making the process much more straightforward and efficient overall. So, as we know, and as we have discussed, and as we have previously mentioned, it's clear that this particular active mode, in fact, most definitely and absolutely requires some form of negotiation process between the parties involved, right? Negotiation is needed, and once negotiation is enabled, the connection can be established successfully. Now, as for this auto mode, which is the passive mode, if both sides are set to passive, it definitely won't work. But if one side is active and the other is passive, then negotiation can succeed. Now, in the case below, where the mode is disabled, negotiation will not succeed. So what about option B? This on mode is a forced enable. I don't need negotiation, right? So the answer is actually very obvious. It's B. I don't need negotiation. Both ends are forcibly enabled. All right, choose B. Transfer. If you want to learn Cisco technologies or get Cisco question banks, please send me a private message. You can also leave a comment below the video for technical discussions.